Hello, everyone. I think it's a good time to start. So thank you for being here. I'm happy to be with you guys today. My name is Ahmed Al-Harbi. I'm a senior account manager at DigiNation. So let me go ahead and share the screen and give you a quick brief about DigiNation. I hope everybody can see my screen. Can you see my screen? Okay. So DigiNation is one of the leading technology consultation firms in the Middle East, um, established in 2009 and specialized in secured, enhanced, high quality and cost-effective digital transformation solution services, such as business applications, intelligence and analytics, AI, infrastructure and operation solutions. Also, data and convergence services, and all professional and outsourcing services. So these all some of the services that we provide at DigiNation. DigiNation has been in the market in the past 13 years and was able to train more than 100 multicultural professional dedicated resources all located in 3 different countries: Saudi Arabia, Egypt, and Jordan, and also 5 different cities to represent a chain of major technologies and a change. Yeah, let me also share the one in the screen. So we are in three countries, 5 different cities to represent a chain of major technology vendors and multi-channels strategic partners, serving more than 400 clients across the GCC. So I will go ahead and talk also about the solutions that we provide. We do all of that by implementing various successful operation partnerships and governmental hero projects. So as we talked about, we do provide enterprise content management, business solutions, and data integration. Also, let me just a second. Yeah. So I will also introduce our guest today, which I'm personally very happy to be with Dr. Rustam Kinga, who led the team that developed what was considered the world's first commercial AI system back in 1891, when he was working for Digital Equipment Corporation. He was vice president of DEC and then Compaq. In 2001, he co-founded iOmniscient, which, as you will see today, is regarded as one of the leading AI companies in the world. This morning, he'll tell us how organization can use AI to increase productivity at zero incremental costs. So, with no further ado, please, Dr. Rustam, go ahead and let me stop the screen so you can go ahead and have the mic and present from your side. I think
and hopefully you can see it now, right?
yeah, you can see the screen. Go ahead. Thank you.
Good. Thank you all for joining us today. I'm really grateful to DigiNation, whom we partner with in Saudi Arabia, because in my view, they are a very skilled company, and they're also a very ethical company. So let me tell you about what we do. Our focus is on autonomous, multi-sensory AI for smart cities. What does multi-sensory mean? Humans use their eyes, their ears, their nose to understand their environment. So we do the same. We do video analysis, we do sound analysis, we do smell analysis, and we use all three together to understand what's happening in the environment. So, for instance, if somebody falls down, you would say, go and help him. But if you heard a gunshot at the same time, you might say, no, don't go there. Somebody's got a gun. So you can change your response based on your understanding of what is happening. Now, we've been going about 22 years, so we are considered the world's longest standing AI-based multisensory company in the world. Um, so we've been doing AI long before it became fashionable. We also position ourselves as an ethical AI company. So you will see as we go through this that we protect privacy of individuals and we make sure that the products are properly used and not misused. Okay, so let's start on something. We do not sell products, right? So our focus is on guaranteeing outcomes for our customers. What do I mean by guaranteeing outcomes? Let me give you one example. Uh, we work with the traffic management people uh, in Abu Dhabi, and their requirement was they want to reduce the traffic fatalities, the deaths on the road that they get. And their initial focus was let's put in speed cameras and so on, it'll slow down the traffic and that'll help reduce fatalities. However, they found that 80% of the deaths were not happening at the moment of the accident. In other words, the people were still alive at the time of the accident, but they died before they could get to hospital. So then, based on that, we focused on reducing the response times. How fast does it take to get the ambulance to the accident site? And then how do you get the ambulances from the accident site to the hospitals? By creating green waves in the traffic lights and so on. So our focus changed in terms of the outcomes that they required. Let me give you another example. We've done many hospitals and aged care facilities in Indonesia and Australia and Singapore and elsewhere. And one of their major issues was that people were falling down, old people were falling down. The problem was they were primarily falling down in the bathrooms. And you can't put up cameras in bathrooms for privacy reasons. So we created for them a privacy protected slip and fall detection system. Let me show you how it works. There, you can see it working. So this person will fall down and it'll raise an alarm over there and it'll send the alarm to the nearest nurse and so on. The key over here is you can't really see anything. You can't see the person. It is fully privacy protected. You just see an outline of what is happening, but you know that the event has happened. Another example, for a number of banks, they were suffering from ATM fraud. As you may know, there are people who put these little skimming devices at the ATM, on the ATM, and when you put your card in, they can skim off all your information. So we've done that for OCBC Bank, for Qatar International Islamic Bank, and so on. So the key was to detect those little skimming devices, but they are very, very small and invisible to see. So let me show you an example of what we can do. So over here, you'll see that I think it's moving. And as we go through, somebody's going to turn up and let me start off. Somebody's going to leave a little, yeah, here he comes. He's going to put a little device on the ATM and he's going to walk away. Now, if you were just watching this, you would never notice it. It's just like a little black thing over there. However, as you go forward, the system will detect it and it'll raise an alarm. And you know there's something there, even though you can hardly see it. Another example was for the Hong Kong Metro. They used to have problems with their escalators. They have something like 5,000 escalators on the Hong Kong Metro. And at any time, about 1,000 of them are not operational. Why? Because little nuts and bolts go and fall into the mechanism and damage the escalator. And then it takes them 2-3 days to get it fixed. So they said, put up some cameras, see if any nuts and bolts fall on the escalator, and we'll stop the escalator. And so that's essentially what we've done for them. So I'm just giving you a flavor for the types of applications that can exist. Here, let me show you how the escalator thing works. So you'll see some nut or bolt falling on the escalator. There's some nuts there, and it'll pick them up and it'll raise an alarm, and you can do something about it. In the Khalid Museum in Cairo, a famous painting called Sunflowers was stolen. And the people in charge said, oh, don't worry. We have cameras everywhere. We will see who did it. So they went back to look at the cameras, and they found that the cameras that were looking in this area were actually not working, right? But they only found that out after the theft had happened. So for situations like that, in fact, what we provide is just a simple health check system. It'll understand what's happening with all the cameras. It'll know if they're working. If they're not working, it'll tell you that they're not working. And it could be for many reasons. Maybe somebody's moved the camera. Maybe somebody sabotaged it. Maybe it has just moved due to vibration. Maybe it can see clearly, but a spider is walking over it. In any case, the system will tell you there's something wrong with my camera. I cannot see clearly, and you can do something about it. So we've implemented systems like this in about 70 countries around the world, including in Saudi Arabia. Over here, some of your systems for the customs, for instance, at the border, are done by us. And we've implemented smart cities in 75 countries around the world, in India, in ASEAN, in Americas, Europe, and so on. And there are about 300 different use cases that we have ready to go, focused on about 30 industries. So let's start from the basics. What are the core technologies that you need to make all this happen? And then we'll focus on how to get value out of these systems. So we said we are focused on video, sound, and smell. So let's look at video first. So in this scene, you've probably seen face recognition systems where they say stand straight, take off your spectacles, don't smile, and they recognize you. So this is a face recognition system where the camera is looking 20, 30 meters out, looking at about 100 people, and it'll recognize them. On a low resolution camera, there's only a 2 megapixel camera, and without any GPUs. You'll see later why we do not require any GPUs. So that was face recognition. We also do complex behavior analysis in a crowd. People leaving a bag, people falling down, graffiti detection. Next, we will do license plate recognition across multiple countries. So we do it for all the GCC countries. So in Arabic and English. And just for your information, we also do it in many other languages like Chinese, Japanese, Korean, Thai, and so on. So that is video. Next, let's talk about sound. So we can differentiate about 30 different sounds like gunshots or people shouting or glass breaking or sirens and so on. And then finally, we do smell. Now, for video and for sound, you have sensors. A camera is a sensor for video. A microphone is a sensor for sound. What about smell? For smell, you get single compound sensors. So if you want to detect oxygen, you get a sensor for oxygen. If you want to detect hydrogen sulfide, you'll get a sensor for that. But most industrial chemicals are much more complex. Like coffee, for instance, has 400 different molecules in it. How will you sense that? So to smell, industrial chemicals, we have built what we call an e-nose. And the e-nose actually looks like this. It's a little device, and as the air goes through it, we can smell what is in the air. So with that, we can smell all types of different things. For instance, in New Delhi, we put in a system for their public toilets. They used to clean it on a schedule every 4 hours. But what if it starts smelling after 1 hour? So uh, the system will tell them and they'll go and clean it. In the food industry, they used to bring in the milk from the farms and it would be entered into the factory batch. But if the milk had gone off, then the whole batch would be spoiled. So now they have a smell sensor to tell them that the milk is okay. In the waste management industry, in fact, in large numbers of industries, smell is a very important factor in managing the environment. So that is video, sound, and smell. Now let's talk about AI technology itself. So what we have been doing, because we've been doing this for more than 22 years, is we've developed AI technologies that go beyond deep learning. Now, all of you will probably have heard about deep learning. So what is deep learning? Just for those who haven't heard of it, it's where let's say you want to detect a dog. You get 50,000 images of dogs, you train your system, and then when the next dog comes along, you know it's a dog because the system has it in its memory and it knows what a dog looks like. But what happens when you want to do something more complex? For instance, for the Hong Kong prisons, they wanted to detect suicides to prevent them. How do you get 50,000 people to commit suicide so that you can train the system? You cannot. It can't be done. So what do you do? Well, how would a human do it? Humans use much more sophisticated uh, uh, methods to understand what they're seeing and what they're observing. So, for instance, a human would say, "Oh, that man is standing on a chair. He's got a rope around his neck. Why is he doing that? He is about to commit suicide." Right? So we combine the deep learning that is very common. Everybody else uses that, and in fact, it is synonymous with AI for most people. But we combine that with these other methods of artificial intelligence, which are actually emulating how humans think. And with that, we can actually address very complex real life problems. We don't need any data or very little data for training. And because of that, we can have very fast deployment. And because of that, it's also very computing light. We do not need GPUs because there's no training to be done. And you will therefore, you remember I said we could do face recognition at a very long distance on 100 people at a time without a GPU. And that's because we use these techniques. Also, in the past, with analytics, you had to fix your sensor somewhere. So you had a camera stuck on a wall or on a pole somewhere. What happens when the camera itself is moving? For instance, on a drone or on a body-worn camera. How can you cope with that? So we have recently started developing technologies that will cope with moving cameras, where the camera itself is moving. And we call that wild AI, where we are doing analytics on the move. And finally, when you've done all this, you can show it on a nice dashboard and you'll get all the results. So having explained the core technologies, the next thing is what makes us different, right? What makes iOmniscient different? So the first thing, of course, is that we can work in crowds, in crowded scenes. Everything we do is in a crowd. Theft in a crowd, fire detection in a crowd, object detection in a crowd. For instance, if you said, can you find an abandoned bag? 100 companies will put up their hands and say, yes, of course we can find an abandoned bag. However, if you said, can you find it in a crowd where 1,000 people walk in front of it, and then after 10 minutes it's still there, then only we can do that. Let me show you a couple of videos to show you how that works. Over here, you can see a slightly crowded environment. And one of the people over there is going to do something. Watch it. It's only one camera, so you should see it. There, he's put a bag down. Now people are walking in front of it and hiding it, so you don't even notice it. But the system has found it, and it has raised an alarm. Let me show you this other video. Over here, you'll notice that we have found something over here. You can see the little red box. It says we found something. Then you press that button. It's a jump to event. It takes you back to when it happened, even if it was a month ago. And you see the person who brought it in over there. He's putting it down and he's walking away, but you cannot see the object. It is black on black. So that's why we call it see the invisible. So you would not see this happening, but the system has seen it happening. Let's talk about counting. You've probably seen systems which count one person, two people going around at a time. Here we are talking about counting in a crowd like that. So you put an area of interest where you want to count. You say how many people are in there. And if there are more than a certain threshold, you can close the doors and you can stop the crowd and so on. Now, in fact, I won't mention where this is, but you can imagine where it is in Saudi Arabia. Now, let's talk about what you do with all this information. You've collected it, you get alarms, you get all these things. What do you do with it? So let me tell you about our autonomous system. Autonomous means it works by itself. So let me tell you a little story. In Brussels airport, 5 years ago, they had a bombing. This person, you may remember the image, he left a bag, it blew up, 30 people died, and then they finally caught him after 3 days. The question is, why did it take them 3 days? Because they knew who he was. He was involved in the Paris event just 1 month before. So why did it take them 3 days? They had the world's best systems over there. They had access cameras, they had Genetec, BMS, and so on, but it still took 3 days. And the reason is that in these situations, they have these lovely big video walls, and they expect this person over here to actually see something. Oops, where is it? Yeah. So if you can imagine, he is not going to see anything. In fact, studies have shown that if you're watching just 2 monitors, after 10 minutes, you miss half the action. After 20 minutes, you see nothing. It's totally useless to have something like this. It's useful for politicians. They like opening these big control rooms and so on, but it's not useful in practice. So what is the alternative? So let me tell you a different story now. In Singapore, they had a riot in a place called Little India. A bus ran over a laborer, it killed him. His friends got upset, they set fire to the bus. So see the timing here, 9:23, the accident happens. 9:25, 2 minutes, the police cars are there. 8 minutes, the ambulance is there. Then the fire brigade. In 1 hour, they've all gone home. Next day, 24 people are charged. How can Singapore react in 2 minutes when in Brussels, it takes them 3 days? What's the difference? And the difference was that in Singapore, they implemented our autonomous response system, where the camera itself understands what's happening, and from the camera itself, it'll find the nearest responder. So it'll find the nearest police car, and it'll tell it where to go. It'll find the nearest, if the car's on fire, it'll find the fire brigade and tell it where to go and what to do. So you don't have to go to a control room and wait for somebody to actually see the event, which they may not see. And then that person in the control will be looking around saying, which is the nearest police car and so on. The system itself does all of that. I'm going to show you a little video now to show you how that works in practice.
iOmniscient's speciality is the ability to provide multiple video analytics in very complex scenes. As you can see, a person has dropped a bag. He has abandoned it and he is walking away. The bag is being obscured by people walking in front of it, and it is hardly visible. The system has found the bag. This is our speciality. We can cope with situations where the object is significantly obscured. We now do the jump to event, which takes you back to the moment that the bag was first brought into the scene. It doesn't matter how long back that was. The system can see who left the bag, can pull out his face, and enroll him in the watch list. This face can then be transmitted to all the other cameras within the network. At this stage, we don't know who that person was, but we do have an image of him, and we can search for him across the various cameras in the network. Now, in this view, we have seen the person again, and we can pull out whatever additional information we have about the person. The next step is to track him. We can track him on different cameras where we have seen him, and we know that he is finally now at that last camera shown in red. From that point, we can find the nearest policeman, and the system sends the information to him on his smartphone. He will ask who this person is, and we can send him as much information as we have on him. He will ask what he has done, and we can send him the jump to event video. The entire process is patented. The ability to find a bag in a crowded scene, even where the bag is obscure, the ability to do the jump to event, and to see who left the bag there, the ability to do face recognition in a crowded scene in a totally uncontrolled environment, the ability to find the nearest policeman, and in fact this entire process of automated response is patented by iOmniscient.
So the key over there was you did not need a control room. Everything can be done on your phone. Everything you did in the control room, you can now do on your phone. The second thing you would have noticed is that this whole system operated like one giant brain. So it's not as if you can say, so on my camera, I will run counting, and on the second camera, I'll do face recognition and so on. Here, all the cameras are working together, thinking together. So camera number 20 will say, oh, somebody's left a bag here. And camera 200 will say, yes, I can see the person, he's now in front of me. Right? So all the cameras are working together as a giant brain. Now, to make something like this work, it has to be extremely accurate, because if it's not accurate, then you'll be getting lots and lots of false alarms, and you'll be sending your policemen all over the countryside. So how do you make it accurate? We make it accurate with something called NAMS. It stands for a Nuisance Alarm Minimization System. And it helps to understand what is real, what is a shadow, what is a dog, what is a man, and so on. So let me give you an example of how it is used. This train that you see is the Sydney Metro train. It's a driverless train. However, in Sydney, there are two train companies. There's the Sydney Metro, and there is also Sydney Trains, where they run traditional trains with guards and drivers and all that. And the challenge, of course, is that they share the track and they share the stations and so on. So whereas if it was running on its own, the driverless train, they could put up glass barriers and make sure nobody walked in front of it. Over here, they can't do that because they're sharing the track. So they decided to put in a CCTV system. Now, the other interesting thing is, which I'll tell you about these two train companies, is that the Sydney trains, they have a huge control room in Sydney with 1,500 people in it. It's like a football field over there. 1,500 people. Sydney Metro has their own separate control room in another part of Sydney with only 9 people in it. So the cost of the system, when people, say, oh, your software is 20% more than the other people's software or something like that, it does not matter. The real cost of the system is right here, right? Because if your system runs well and it is autonomous, right, you save a massive amount in terms of operating the system. So these sorts of autonomous response systems can be useful in many places. In traffic, you saw how it was used for the Singapore traffic system. It can be used in hospitals. Somebody falls down in a toilet, you find the nearest nurse. In access control systems, you don't need anyone watching the gate. If somebody enters incorrectly or is stuck over there, the message goes to the nearest guard who can then go and help them, and so on. In every environment, you can use an autonomous response system. The other thing we've done is that we've designed the system to save on infrastructure costs. So it runs with less storage, 90% less storage, less network bandwidth, no GPUs, and less manpower. We need far less cameras with a very low resolution, as you saw on that face recognition video. And let me show you how we save on storage. So over here, there's a car park. You'll notice that this man is wandering around and looking into the car, so we'll catch him. Look at this car. It is not parked legally, so we want to catch him as well. The system, well, let's watch both of them. So you see this person is looking into the cars. The system will catch him. It'll zoom in on him. When he turns around, we'll recognize him. It'll find the car. It'll zoom in. It'll read the number plate. Now, what was happening here? Let's say it's a high resolution camera, 2, 3, 5 megapixel. We've reduced it to 0.1 of a megapixel because that's all we need to do the detection. Then when something unusual happens, we can go in, we can pull out the person's face or pull out the number plate and do the recognition. Now, the key over here is you don't have to store and transmit all the video at high resolution. You only need those little bits at high resolution. If you want to recognize me, you don't need my shoes in high resolution, only my face. So doing that, you can reduce the storage and network bandwidth by about 90%. Let me give you an example. We did a very large prison, and the customer said, we love your technology, it's fantastic, but we have no money. And we said, you're going to spend $2 million on this prison. And they said, yes, but your software is $600,000 more. We don't have that. Finally, we convinced them to do it all together. They saved $800,000 just on the storage. So the whole system came in at 1.8 million instead of 2 million. The value proposition we provide is that it is less expensive to make your system smart than to leave it as a dumb recording system. And the total system, how much does it cost? It costs about less than a cup of coffee a day, about $2, $3, $4 a day per camera. And it'll run wherever you have computing, because we don't need a GPU. It'll run at the edge, in the data center, in the cloud. And once you've done all this, that's what you call a smart city. A smart city consists of many different things. It's not just roads. It's schools, it's hospitals, it's shopping malls, it's a number of different things. For instance, you have buildings. So in a building, we have solutions for buildings, for access management, for parking, for safety, for evacuation management, and so on. You might have a construction site. You have systems for uh, managing the construction site. Are people wearing their PPE, their helmets, their jackets? How long do the trucks come in there to dump their stuff and pick up stuff? Is there intrusion at night, and so on? For each type of industry, we have an industry pack. So if you're in the oil and gas industry, we have solutions for security, for safety, for operations, for oil and gas. If you're in the roads business, managing roads and traffic, we've done many roads around the world, in the Philippines, in India, in Malaysia, and US, and so on. There we have an optimized traffic management system, which will optimize the traffic lights. It's integrated with a safety incident management system. So if there are accidents and so on, the same system will understand all that. There's an integrated law enforcement system. If it'll catch speeding, it'll catch red light camera violations, and so on. And finally, there's an autonomous response system tied into it. So when something happens, the right person is advised and he can come there and he's told what to do. Let me share another concept with you, and that's the concept of a video utility. When we first went to Singapore, there was like 7 different agencies. There was the police, there was the Land Transport Authority, the Environment Agency, and so on, and they all had their own network cameras, their own network of cameras. And they did not want to share the video because they said it's confidential. So finally, we convinced them thing, but they would not share their video. So finally, we came up with this concept of a utility where one agency runs the utility and everybody just gets what they are authorized to get. So if you are responsible for the environment, you will only see the dustbins which are overflowing. If you're the traffic police, you'll see the car number plates of people speeding, and so on. Let me now help you through an industry pack, a vertical industry like retail. And because as I said, we build these solutions for many different industries. So in retail, what benefit can they get? Just a minute. What benefit can they get? So we've done many retail malls all over the world. And retailers, the first thing they look for is customer information. Things like dwell time. How long did the person spend in the chocolate section? How long did he spend in the vegetable section? Queue management. Young ladies walk towards the monitor, then the monitor will show ads for lipstick. If 10 old men turn up watching towards the monitor, it'll show something else, and so on. And it'll analyze the demographics. How many people walked past the store? How many turned to look at the ad? How many entered the store? How many actually bought something? Were they male, female, old, young, and so on? And you can show all this on some dashboard. But retailers don't only worry about customers. They have to worry about logistics and distribution. They have to worry about parking. They have to worry about security and safety. So they have different departments looking after many different things. For instance, security and safety, they have to worry about finding lost children. They have to worry about spills of water, spills of milk, rice, whatever on the floor, detection of slips and falls, and so on. In the logistics department, let me give you an example. In a large grocery store, the trucks would come and leave ice cream pallets on the floor over there, and the ice cream would melt. So they needed an alarm to say there's ice cream sitting over there. It needs to be moved to the fridge. It's been sitting there for more than 2 minutes. Right? So it helps in many different parts of the organization. Large shopping malls, they have to worry about parking management. not just how long did the car spend in the park, but also how many spots are available and where to find the car, especially in large car parks where you can lose your car. Also detecting accidents, detecting fights. All these things happen in car parks. You have to understand those things. So the retail pack is a very comprehensive pack addressing all the different requirements of a retail environment. Now let me discuss something that goes across the board, across many industries, something like access management. Now, access control is very simple. You probably have a card and you use it to enter your company. But the problem with a card-based system is that I can use your card and it's easy to defraud. And as soon as you have a system like that, then you need a large database, which means it is open to hacking. And of course, it's not scalable because then you need a database in every city, in every country that the company is in. So how do we solve that? We've built a system where your database is on your own phone. You own your own database. And when you enter an environment, the camera will pull your data out of your phone, your metadata. It'll compare your face to that data and it'll say, yes, you are the right person, you can come in. And the advantage is it's fraud-proof. If you lose your phone, nobody else can come in. There's no database, so there's no risk of a database breach. You can have large crowds going in because it can be gateless. And it can be multi-facility. So, if you have an office in New York, the person from New York can come to the office in Riyadh and the system will let him in because it'll pull out his data from his own phone. Now, what we do is we provide software. We are a software company, but of course, the solution involves cameras, computers, and so on. And we can provide a total solution. But more important, the key problem that people have is making it happen. The reason for that is everybody's talking about AI, but very few people have actually done it. So we help our customers do the risk analysis. We help them with their process re-engineering. Then we help them design the system. Then we'll do the turnkey implementation, along with partners like Digination, because we've trained them. And then finally, we provide the 24/7 support along with them. There's an organization called Gartner, which lists all the major companies in each industry. And we've topped their list for computer vision companies as having the most comprehensive list of applications for the last 3 years. And all the things we talked about today, they are protected by about 70 international patents, which means that a lot of people use our system. So if you bought a Lenovo Smart City, you'll get our system. If you bought a Cisco Smart City, you'll get our system. If you got a Hitachi Smart City, you'll still get our system. Last year, we were Intel's Alliance Partner of the Year. And we are key partners for other people like Huawei and so on as well. We have our own teams in many parts of the world, including in several countries in the Middle East. In Saudi, we work through our partner, Digination. And the key point is we have all this now. It doesn't have to be built, it exists. And so what you noticed in this talk was you can do a whole bunch of very interesting things focused on your outcomes, solving your problems to make you more productive. And it'll actually cost you less than a recording system if it is designed correctly. I will stop now so that I can allow some questions from the audience. So I'll stop
Absolutely.
sharing.
Thank you, Doctor. It was really intensive, and all the details that you said was really nice. So we already have some questions that were added in the Q&A section. Also, anyone would like to ask anything, feel free to ask Dr. Rostam. So one of the questions, doctor, is that if a person changed something of their appearance, how can the camera identify him or her?
Well, as the name says, it is artificial intelligence, so it emulates human intelligence. So you would look at it and say, how would a human do it? And it'll do it the same way as a human would. How would the system recognize someone who's changed their appearance? If it's a small change, it will still recognize it just like a human would. So if he's just grown a beard or if he's wearing spectacles, it would recognize him uh, with a certain level of accuracy. If he's had plastic surgery done and he looks totally different, the system will not recognize him, just like a human would not recognize that person.
Okay, perfect. So another question saying, is it easy to repair or maintain the system if something goes wrong?
Yes, the system is designed to be managed remotely. So we've implemented entire smart cities remotely without actually going there. We did one in Kazakhstan. But of course, in Saudi, you have Digination. So they are local, they are trained, they can implement the system along with our own people. They can implement the system for you and they can maintain it for you. But these systems, once they're running, they will keep running for months, for years at a time. So the key is to make sure that they're working when they start. And they're very straightforward and easy to maintain. We provide a 24/7 support capability. As a second level support, Digination would provide the first level support in Saudi.
Absolutely. Okay. So another question, Mohammed is asking, so he's interested to learn more about how such technology can be adapted in the higher education sector, from the education perspective, not the administrative.
In the education perspective, I don't know. Because I don't think we've done that in the education, on the education side. There are people who use AI as an educational tool, and we'd have to think about it, and we could discuss it with Muhammad later on and brainstorm how we could use it. For us, the way we have used it in the past is for um, protecting the environment in a school system, for instance. They wanted to make sure that the kids were always picked up by the right people at the end of the day. It would handle attendance so that you don't have to spend your time saying, Dima, are you present? Aida, are you present? And so on. So there are many use cases that we have implemented. There are obviously people who do that, and we can discuss how the technology could be used in that segment.
Very nice. Okay. So we have many questions. Okay. So another question says, Dr. Rostam, thank you. May I know more examples of smells that may be detected? Also, on the e-nose, very expensive. Is it expensive, the e-nose?
Well, as with all these systems, the cost really has to be justified by the value it provides. So, for example, in that milk food processing industry example that I gave you, if the milk that comes in the trucks from the farms, if it is spoiled and it enters the batch in the factory, then they could lose about $100,000 worth of milk in one shot. So if you put in a system that'll smell it and it'll save you $100,000, then it doesn't matter if it costs you $5,000 to do that, right? So the value, you always have to do a return on investment to make sure that the system is useful to you. How many applications are there? There are, with all these things, there are hundreds of applications. I'll give you one new example of that we are still working on. So it's not a released product yet. But we found that with our smell system, if people breathe out into the smell system, we can collect that breath, and it can be used for early diagnosis of breast cancer and lung cancer. So we've done clinical trials in 2 places, and we got extremely good quality results. Now we are looking to see how we do much more extensive clinical trials, because you need to do that to get approval in the US by the FDA and other places like that. So you need very extensive trials. But you can see the type of applications that can evolve from devices like this.
Okay. So we have a lot of questions. So someone is saying, thank you, doctor. Can you tell us how huge some of the biggest projects are? How many cameras were used?
Well, we do big projects and we do small projects. If somebody has 4 cameras in their coffee shop, we will support them. But our biggest projects are things like we did the China fast train, and that was like 7,000 cameras. Singapore smart cities, more like 20,000 cameras. So the big projects are in the thousands of cameras. But not everybody has a big project. A hospital might only need 200 cameras, or a school might only need 20 cameras, right? So we support both small and large customers.
Okay. So another question. Sorry, we're taking a lot of your time, but people are asking. So as you described, you operate in many domains. So who are your major competitors?
I think if you look at any individual area that we operate in, we have competitors. So if you said, look at face recognition, then there are about 20 or 30 companies who do face recognition. And in that space, we differentiate ourselves because most of those companies do it at close range, where they can do one-on-one recognition, like in airports for passport control and so on. We differentiate ourselves by being able to do many to many at long distances without a GPU and so on. So in each domain, there are competitors, and we determine how we differentiate against them. I think overall, we do not have a competitor, because there is no analytics company that actually does the full range of things we do in video, sound, and smell. At least not one that I'm aware of. So we don't know, for customers who say, look, we want a very comprehensive solution, then I don't think they have much choice. There aren't any other companies who do everything.
Absolutely. Okay. So another person is asking, can the system be used on the move? If a car is equipped with cameras, can the system still give results?
See, the traditional systems worked on fixed cameras, as I mentioned. Today, we are evolving the technology to do things on the move. It is still very early days. There are certain things that we can do on the move. For instance, in Hong Kong, we've implemented a traffic system where we use drones to look for congestion and things like that. So there are a limited number of things we can do on the move today. So I wouldn't say we can do all the things that we do on the move, but it's evolving. The technology is evolving. It's still a very young technology. If you think of aeroplanes, back in 1905, the Wright brothers flew the first plane. In 10 years, in 1915, they were flying planes in the First World War, where the pilot would lean out of the plane and he'd drop his bomb, hand drop his bomb. And today, 100 years after that, we are landing on the moon, right? So I would say in things like computer vision and video analysis, we are still in that early stage where we're dropping bombs out of the window, right? It's still a very new technology. It's only 20 years old. We only started 22 years ago. Um, so it'll evolve in 50 years' time. Who knows what the technology will be able to do? It'll do some amazing things that we cannot even imagine today. But at least today it's working.
Absolutely, yeah. Okay, doctor. So the last question, because we're out of our time, but let's like end up with this question. So how the person's asking how to start. What criticals should we use in hiring a consultant?
This is a challenge because you will find, even when you go to the big four like PwC and KPMG and so on, everybody talks about AI, but nobody's actually implemented these systems. So you need to find someone with the background knowledge on how to do it. So what you should be asking your consultant is, have you done it before? And can I have the person on this team who has done it before? Right? That is critical, so that he has some experience. He knows all the problems that they are going to face. How to, for instance, people often buy the cameras, they put the cameras in, and then they think about what analytics to put in. The first thing you have to do is to understand what problem you're trying to solve. And then you decide what types of cameras you need, and then you implement them, right? So even simple things like that are things that a good consultant would be able to advise you on. I would say that's, a company like Digination, they work with us, and therefore they have access to all our expertise in many of the different countries we've worked in. A company like Digination would be a good consultant to go to, just because they have the expertise and they have access to expertise from a company like us.
Absolutely, Doctor. Thank you for your time. And at the end, I would like to encourage everyone to drop their LinkedIn account in the comments, because we're gonna do like a random a pick for a prize. This prize is going to be worth 10K, 10 Saudi K, and it's all about assessment and support from the iOmniscient team. And this support will make any company or any person that wins to understand the issues and the environment, and give reports on the technology that they could use to improve productivity. Thank you for your time. Thanks everyone for joining us. We will upload the session on our YouTube channel, which also we will post on LinkedIn. The prize will be posted on LinkedIn as well. You can find us on social media, Digination Mia, and hopefully, Doctor, we can talk again someday. Thank you for your time.
Yes, thank you all very much. I'm going to be in Riyadh in about a month, less than a month, to meet with the Digination team, and we'll be exhibiting there at Intersect. So I look forward to meeting some of you at that time. Thank you.
Yeah, thank you. Thank you, guys. Thank you, Dr. Rustam, for your time.
Welcome. Bye, everyone.